Hello. Welcome again to another lecture at Kente Code AI. We are still on our Python and SQL Foundation series, and today we are going to discuss about data visualization. That's basically after all your data cleaning, all your analysis, you need to present the data to business users in some kind of form. It can be any type of plot, graph, so they can usually descend from your analysis and that kind of work. So in Python, yeah, we have to do this in order to present this visualization. So today we are going to go into the topic of how do we show graphs of the data so business users can be able to easily understand what is our finding. So without much ado, let's get into it. Okay, so the topic is data visualization, and we are doing it with two main libraries in Python. The main library is Matplotlib, this library, and then the advanced form of Matplotlib is called Seaborn. So the objectives, we want to learn how to plot graphs with Matplotlib and Seaborn. So we will start with the Matplotlib library first. So Matplotlib is a Python library, very powerful. It can be used for different type of visualizations in Python. You can use it with pandas and also NumPy or any data array. NumPy, pandas, yes, that's it. Or any data in that form, you can give it to Matplotlib and then plot a graph or plot a line graph or what type of graph you want to plot. Is the sky is the limit for Matplotlib. Okay, so it can be used for 2D plotting of graph. You can create line graphs, scatter graphs, bar chart, histogram, and more. You can customize it, be able to show visualization in different form. So the main key concept in the Matplotlib is you have a figure which actually describe the area where you're going to draw your graph. It's called a figure. Okay, when you come into the plotting terms, figure is where you draw everything. So you can have the row, the size. Just imagine you have a square, or you are going to draw everything inside. That is your figure. Then we have the axis. So the axis are where the data is plotted. You can have x-axis, y-axis, and the plot itself is the visualization, like the line plot, bar plot, whatever it is. So we will talk about different type of plots that are there. We will not go into every single one of these, but they are there. You can just go and then try to find different types, but they are there. You just ask for it and then get it. So you have to install the library Matplotlib. Okay, I mean, if you don't already have it, you install pip install Matplotlib. Okay, in this session we are going to do NumPy, Panda, Seaborn. So you have those libraries there. So like after you have them installed, just make sure you have the Matplotlib, you have NumPy, we have Seaborn. Pandas is also there. We are going to use in this lecture. So, but the first point is how do we use the Matplotlib? So let's go into how. So as I said, we have different type of plots. The simplest plot is a line, like you draw a line on the axis. So for example, I'm generating data for a line. So I have y-axis. So if you have graph, we have the axis. The y-axis is the vertical one, and the x-axis is the minimum. If I have to draw that for you to see, but it looks like. Let's go to here. So if you have something like it will look like this. Okay, if I want to draw a graph, so I'll be like this is your y-axis and this is your x-axis, right? So you take a point here. Let's say this is 1, this is 2, this is 3. Okay, and then this another on the x-axis you have 1, 2, 3, 4. So graphing makes, so if you have a point of 1, comma 2, that is 1 point. Okay, That's 1 point. You want to plot this on the graph as is. This is 1, 2, 3, 4. That is your graph. So you, for the first one is x-axis, so 1, you say 1, and then 2 on the y-axis. So where you plot this at this location, okay, where the two of them meet, you make a plot over there. So let's say you have another one called 2, 3. That's another point you want to plot. You go to 2 on the x-axis and then 3 on the x-axis. So 2, 3 here. That's another point. So let's say you have another one, say 4, 2. Okay, that's another point. So if you have that point, you go to 4 on the x-axis and then 2 on the y-axis. So 4. So this is 4. And then this is 2. So where they meet, it will be somewhere here, right? So now you have all these together. In a line graph, you connect them together with a line, okay? So that gives you this type of graph. So that is a line graph, okay, in practice. So that is what we call a line graph. So if you have a data set, so for example here, I'm just generating numbers from 0 to 10, 100 of them. That is the meaning of this. This is NumPy function line space, 0 to 10. Between those range, I'm generating 100 data points. Okay, that's what this means. And then y-axis, I'm just finding a sign of each of these numbers in the x-axis. So sign, these are mathematics sign calls and those, that's math. So the y-axis and the x-axis, at the end, I have x-axis have 100 points here, between 0 up to 10. And then the y-axis is finding the sign of all those values, also 100 points, right? So now I have these two x-axis and y-axis. If I want to draw a graph of them, a line graph, I'll just go ahead and, okay, so this is how I'm going to draw the graph, okay? Forget about me manually doing that. Plotting all the 100 points on it will be so long. So if you want to define how you are going to create a plot, so first is you specify the figure. I said the figure is the square area we are going to plot the graph. So you specify it and you give this is the row, this side. You give it's in pieces actually, and this is the column. So 8 pieces, 4 columns. So imagine is 8 is the measure of this from here to here is 8, and the measure from here to here is the 4. So if you are trying to adjust the size, you have to change this number so that you get the right figure. So here figure, you specify the figure now. Okay, this is the first thing you are going to do. You specify the figure. Then the next thing is to plot the points. So for the line is called plot. So PLT is the, so we said in the beginning we said import matplotlib.pyplot. That is the function that is used for plotting the graph as PLT. In Matplotlib, the function that plot is called pyplot. So we are importing as PLT, and then everywhere we want to use the function pyplot, we just say the alias PLT. Okay, the same NumPy, we import it, and we have the alias NP. That's what we are going to use for Seaborn. We will be using SNS. So just know that. Okay, so here, after I have that, so I say PLT.plot. That's how you do a line graph. Then you specify the x-axis and the y-axis. That is the data for the x-axis and the data for the y-axis. And then you can give the label, like what you want to call these. Like the label is what goes on here. Okay, this line, this is the label for it is called sin x. Okay, that's the label. Okay, sin s. Okay, now after plotting the graph, you can have title. So you want to give a title. So say plt.title, then you give the title. Now you can also label the x-axis and the y-axis. So you say plt.x label, then you give how you want to label it, .x label, and then plt.y label, what you want to label the y. And then here, plt.legend just means that do you want to show the label. This legend is going to show the label that this graph has. Okay, if you don't have if you don't put a plt.legend, then this will not be showing. Okay, now these are just custom. The grid means that do you want to see this grid, like in a graph sheet itself, there is a grid on there. If you want to see the grid, then you say, yeah, I want to see grid through. If you take this out, then the whole of this will just be plain white page. And then after drawing the graph, it's not going to show until you use the command plt.show. So after doing everything without plt.show, you not see the graph. It's still there, but you can't see it on the physically. So it's a plt.show will now show everything that is drawn behind the scene on the screen. So this is the line graph. Okay, this is your y-axis, and you label it y label as sign of x. That's the label you gave it to it. And then the x-axis, you label the x-axis here, x label as x, right here. And this is the title. You put the title from here, plt.title. You give the title, so the title goes over there. And then this is the legend. That is the label. When you say legend, the legend will show you the label for the graph. So this is how you read this is how a line plot looks like. Okay, this is a line plot. All right. So how do you read it? So you say each point on the line represents a value. Yeah, remember, at a specific position on the x-axis, right? On the x-axis and the y-axis, this is the x-axis too, and the y-axis will be the value that will be here. So every point represents the value of the two things. They connect, the lines connect at a point to show like the trends. You see here is going up, it reaches a maximum, then it goes down, and then it goes up, and then you go down. Okay, this is what it is. And then you look for upward trends like the peaks. You see the peaks, the values, and the changes in the slope. You know, you see here it goes up. So this one has two peaks over here, one value over here. So depending on the value you have, so you can have multiple lines, you can have multiple line graphs, and then you can compare how those two things are going over time. So we see something like that. Okay, we can customize the line graph. So for this is the same graph. We are just changing, customize it. The figure is the same, right? And then we are plotting x and y. Okay, the same data we have, but we specify a color so that this color will be red. Okay, and then we say line style is hyphen. That means this, you see this one, when we are joining the line, what you are using to join is these two hyphens. That's what this means. And the marker equals the zero over there, means that where the point is, you use that zero marker. Yeah, zero, like the dot here, each of these dots, those dots, that's the marker. Yeah, and then the label is just this one. Everything else, the title, everything else remain the same. So you can customize it and have it in different way how you want the line to do. The customization is you can have multiple line graphs, as I was saying. So for example, we have the same data set. We have x, the same number, but have y1, which is the sign, and then the y2 is the cost. Okay, these are mathematical functions. So here we have the figure still. You still plot the figure. Then look at this. The first plot x against y1. Label is sign x because y1 here is sign x. Yes, this is sign of x, and then it plots. You see, you just say plot, then you plot the second plot. The second one, x against y2, and the label is cos of x. And now you just give the labels, the title, the labels, everything remains the same. And now you have two graphs. See, this is for the sign, okay? And this yellow one is for the cos, okay? And when you say legend equals true, legend, you specify legend, is going to show you this over here, show you that this is the sin s, and the blue one is sin s, and the yellow one is the cos s. Because if you say legend, it's going to put these titles, labels that you gave here, it's going to use those labels and show you so that you can quickly see, okay, this is, the labels for each of the plots. So yeah, you can have multiple plots on the same figure or in the same thing, but you can also have them as sub plots. Okay, see this one, they are all on the same x-axis and y-axis together, but you can have it so that they'll all be on different. You see, this is one on one axis, or on the, but they are all in the same figure. You see this figure? What happened is this, that this one is called a subplot. A subplot because we say, okay, we have the data. So the data set, you get the data, just we get the data. So what we do now is we say figure and the axis, then we say plt.subplots. That's the command you are going to use if you want to have the graphs on two separate plots. Now, okay, then you specify how many of these you have. This is one row, and this is a second row. So the first value in the subplot is telling you, do you want to have one and then two? That's the number of rows. Just take a glass. Each section is a row, and then the number of columns mean one. Mean one. This means the whole of this is one. If you specify this to be two, then it's going to break this into 1, 2, 3, 4. It's going to be having 4 different locations to plot the graph for, and then you just the size is just the fig size. Okay. Now you say fig and x. Okay. You specify 2 variables. If you go back to 2 variables like this, if you go back to tuple, if you go back to tuple unpacking, if you remember that concept. So it says that if this whatever you create here will have a figure and s, so you unpack them so that you can get a figure and you can have the axis. Okay. Now the axis will be, this is axis 0 and this is axis 1. Okay, so you take axis 0 and you plot the first plot in there. Okay, x and y1. Okay, you plot it, and then you plot. You set the title for it. You put the legend for the axis 0. Then you just go to the axis 1, which is the second one, and do another plot on there. Okay, all these are just adding to it to make it better. So now you have 2. They are all in the same figure, but there's one at the top for sign separately, and then there's the cost sign, the cost function also separately. So those are called subplots. Okay. Now another type of plot is called scatter plots. Okay, scatter plot, you have the same point. So you have data point x and y, and you want to plot a scatter point. So this one, you just plot them without, you are not connecting at the point. You are just plotting the point, the x and y, whatever they meet, you plot them, but they are not connected. So the point are scattered around. So it's scattered point. They are not connected like a line. So you just plot all the point. And this particular type of scatter plot is actually good if you want to read it. This is what you get. Each of the point, they represent an observation with its x and y values. So each point here is an observation. Okay. Now the position of each point shows the relationship between two numeric variables. Like if you see here, this is x here and this is y here. You see here, this is x, and then this is the y value over here. Okay, there you can see patterns, you can see trends or classes can indicate correlation. You see, like these things are like, you see some of them are together over here. This will be like they form some classes. If you see, they form some classes over here. An example of this, for example, like if there is a disease outbreak, and then they are saying, okay, take for example longitude, latitude for cities. Okay, so you know the latitude and longitude. So if there is a person who got a disease like the COVID, you come here, you find what is the longitude, what is the longitude, and what is the latitude, and make a point over there. And you do that for all people around the world. You see that where the disease is actually spreading, the city, that latitude, you start having these clusters in that area. So when you plot that data, you can visually see, okay, this city is having more of the disease, because there will be more clusters in that city, and the cities that don't have the disease will just have scattered points. So scattered point plots are really good in identifying those issues quickly. Okay, scatter plot. This is the basic one, but you can also have it with colors to show, hey, the intensity. The color will tell you, hey, this is happening so big over there. So if you want to do with colors, you specify the colors you want to use for plotting it and how big you want to. The alpha is how transparent you want it to be. So, plotting the scatter plot, we say plt dot scatter. Okay, I didn't mention that. So the scatter point, the only thing is the word to use to plot the graph. Okay, instead of plot, here is scatter. Okay, it's that simple. The name actually just represents what it is. Okay, and if you want to give it colors, so let's say for this one, right, I have x-axis have 50 random numbers, y-axis has 50 random numbers. Colors, I give numbers of 50 random numbers, and then the sizes, I'm getting 50 numbers, random numbers. It's on the normal distribution line, and then I multiply it by 1,000. So this is just going to show the size of these points. Okay, 50 of them. Each of them, they are randomly picked, and then it's going to show you at each point how big this is going to be. So the figure, the same figure has says for how the pixel length for this, that is it. And I say scatter, plt dot scatter. I'm going to put the scatter plot, and I specify these two, x and y. Now c equals colors. Okay, so c equals colors, and then s equals the sizes over here, and alpha equals this. Alpha is the transparent you want these colors to be, and C map is color map. So these are some things you can just vary. This is a type of color map. I think it's from purple to yellow or something like that. So what this means is that we are taking a particular color range, and we are going to be plotting the graph based on how intense the size is. The size will be big, and then the color will be transparent, or it will be more thicker. As things become, like a lot of them are in that area, you come to see that it will become more thicker in that area because a lot of things are happening over there. The intensity will be showing in the color palette. So that's a way, like, look at this place. You now start to see that, okay, there's something happening here, and you can quickly see how it is. Okay, that's just to use the color to show you. And now bar plots. Okay, for example, I have apples, I have bananas, I have cherry, and I have mango, and then I have how many I have them, and I want to draw a bar chart. So a bar chart is basically, you see, you use the plt dot bar. Everything else is the same. You specify the data you have, and then the next thing is the count, and then color you want to use. Here I'm using sky blue, and the title, the labels, and all these the same. So a bar chart looks like this. It's a category. So this apple, you give the category, and how many apples we have, that's how tall the bar is going to be. So that, like here we have 10 apples, so the bar goes up to 10. The bars are the same size, the same width, yeah. But the height will tell you what is the number. Like this one, 24 for mango, banana, and then cherry is 36, like this, and then mango. So with this, quickly, anybody can just look at the graph and say, okay, we have more cherry. Okay, visually, you send this, everybody will know it. But if you give this data to people, they now have to be looking and say, okay, what is 36? What is cherry? Okay, so that is why the visualization from a chart or a graph is really important. So, you give it a business, everybody can quickly see what is going on in the business. Okay, so you have to read it. Each of these bar, they represent a category, each of them, and the height or the length of the, it shows the value or the frequency for that category. Okay, the x axis or the y axis for the total, it lists the categories, okay, and the show, and then the y-axis shows the values. Okay, you can compare the heights, yeah, okay, to see which category have the higher or the lower values. That's how you can compare it. They are useful for comparing quantities, yes, across discrete groups or categories. Yes, that's the most important point. That's what the bar chart, bar graph can be, a bar plot can be used for. Okay. Now the next one is a histogram. Okay, so we have a data set. So data set of some values that we have. So a histogram, on the other hand, okay, let me say something. So let's say I have some numbers. So these are just some random numbers. Okay, let's say I say negative one, 0, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then I put a B that, okay, 1 to 5, 5 to 10, 10 to 15, 10 to 20. I have those being, and I have all these numbers, small numbers, zero point 0.5, point 0. Then I'm like, how many of those numbers lie in this bin? That will be the count of that bin. And then the next bin, how many numbers lie in that bin? That will be the count. So that's what a histogram does. It has a bin. Okay, it's the same size. Like if it's the size of the bin is 5, then it will be 5, and it will count the data set that you have. How many of them in that particular range? That becomes the height of the histogram. Okay, so let's see how it is drawn. So we have the figure. Okay, then we have the data, which is the data we just got these numbers here, thousand of random numbers. Okay, now the beans is equal to 30. 30 means I want 30 beans. So it's going to divide the entire thing into 30 columns, okay? And the color is orange, color edge is black. Those are just decorations. Title is the same title, the S, and then the word frequency and the value. So when you have these 30 beans now, this is like 30, it will divide the entire data set into those 30 beans, okay? And within each of them, it's going to count how many numbers in your data that you have, how many of them lay there, and that will become the count for this one. Then to go to the next bean and then the range and see how many numbers live data live there, then that is the count to become there. So it will do all these for everything, and then you have a histogram. And that's a histogram. A histogram is really good. So each bean or the bar, each of them is a bar. It represents the frequency or the count of the data points within a specific range of values. Yes, that's the data. It's counting them or the frequency of them. So the x-axis shows the value ranges. Yeah, this is the, and the y shows the frequency. That's the Y. Okay, the taller bars mean more data points are in that particular range. Yeah, okay. And the shorter one means that there's fewer data points there. Okay, the shape of the histogram, it helps you see the distribution, right? There is normal distribution, there's skew, there's bimodal, there are outliers, and then you can understand the spread or the central tendency. So if you see the histogram, you see this, it goes like this, you see the spread. Okay, and then it goes like this. There are normal distributions, there are skew distribution, there are bimodal distributions, but those are not. You can read more about those things, but that's the shape that you can read from histogram. Okay, we got another plot called a box plot. Okay, box plots are really actually if you are doing analysis deep and see if you actually identify outliers in your data, that is box plot. That's what you're going to use. So we have, okay, here I have some data. Just I generated some random data is in my data. Okay, I'm going to plot the graph on a figure, specify it, and the keyword you use here is box plot. Okay, then you give it the data. Okay, forget about all these the ticks and all these things here. These ones. Okay, vertical, true, vertical, like you want them vertical, you see, true, that means the box plot is vertical. Okay, patch artist, I don't really know a patch, but the tick labels A B C is this 1 2 3, the ticks A B C, now these are the three ticks we have. All right, so but what I want you to see is how to actually, so the labels, we have the category and have value, how to actually read a box plot. Okay, let's go into reading it. So once you have your data set, this is one data, right? Just one data set. You have a data set. Okay, now here you can read it by seeing it shows the interquarter range, which contains the middle 50%. You see these yellow lines that are in the middle. Okay, for this A, this is the middle value. This is the half of it. Half of the value will be below here. Half of the value will be below there. Okay. Half of them, this one, this category B, half of them will be here, and half of them will be here. And see, half of them is here, and half of them is over here. All right. Now, if the line inside the box matches the median, yeah, the middle value. Okay, that's what it means. And the whiskers extend to cover the range. Okay, the whiskers extend to the smallest and largest ranges within the 1.5. So these whiskers extend to how far they have gone to the top and how far they come to the bottom. Okay, and then the point outside the whiskers, these are the outliers. So if you draw it and there's a point here, it means that there's an outlier in your data set. Normally when we are doing machine learning, we look for outliers in the data set and then try to identify if we need to keep that outlier in the data set or not. If not, we take it out, or we need to find what that outlier is and try to find a reason for it. Okay, and the position and the length of the box plot and the risk, it helps you see the spread, the skewness, and the presence of outliers in the data. Okay, they are useful for comparing distributions, spotting outliers, and understanding data spread and symmetry. So you see this one, you can see A, right? You can see, okay, A have a very small spread. You see this one is shorter, right? So A's values are within just from negative 3 point something here to 2, but B values spread from negative 4 to 4 something, 4.5 or 5, something like that. So B has a bigger spread, covered bigger spread. C is even bigger. The spread is so big, right? And then there's an outlier. Okay, now if you are looking at these values, the middle is, so assuming this is a restaurant A and this restaurant B and then restaurant C, and then you are comparing the pay that they give for employees. Okay, then this middle point will be where the median payment, the average payment is, and people who got paid above the bottom line at the red line will be those who get paid higher. Okay, and the rest of the people are below this are the people who got paid lower. Okay, so like this one, we say, okay, the highest pay will be here. Everything down here is here, and then how many people get more a higher percentage pay will be what is here. And then here you have, this is telling you that, okay, it's not like everybody is getting higher pay to the here. It's just that, yeah, to here, this number, yeah, we have a distributed value, but here it's just that we have some small numbers that get this kind of pay. It's spread up to there, but it's not like everybody from here to here get the same higher pay. It's not okay. It's telling you how spread the payment is across the employees. Okay. Okay, another graph is pie chart, very common graph. So here, for example, right, we have apple, banana, cherry, and the mango. You see how many we have the same graph. So you want to plot a graph, a pie chart. You have the figure. Then you say plt.py, and then you give it the sizes, which is this, that, right? And the labels, which are the labels that you are plotting them for. And auto PCT, this is just some values you can customization. The title, pie chart, okay, and then show. So now you see that we have a pie chart. This is 100%. The title is 100%. Then each of their sizes will get a percentage. Basically, it's like 30 over the total times 100%, then that percentage mango get this. So when you see this graph like this, you can quickly see, okay, the highest one, which is bigger here, 30%, then followed by this 25, 25. Sometimes it's good to put the percentage inside like this. Okay, most of the time it's good to put it like this because still some people might not be able to see that okay, apple is bigger because I mean maybe they have some color problem. So it's good to put the percentage itself inside the chart so that people can easily see the values in addition to the size of their parts. Okay, so that's how it is for pie chart. Okay. So for the pie chart, as a pie, each slide represents the category, and the size of the slide shows the proportion of that category relative to the whole. Yeah, the sum of all the slices equals 100% of the data. Okay, you compare the slide sizes to see which category is larger or smaller. Labels and percentages like this, okay, they help interpret the exact value for each category. Go to put the things in here so you can quickly see it. Okay. Now, another chart, this one, you might not see that common, but it's an area chart, a plot. So you are going to plot the same thing. So here I have two variables. I have x, okay, then I have y1, I have y2, okay. I have these two variables, okay. Now I'm trying to plot on this figure, and this area plot, we plot it by using what is called the stack plot. I have x, y1, y2. I give it label y1, y2, alpha, and how transparent it's going to be, and I give it title. This is the title, and this is X, and this is the Y values. Okay, legend to show, and then PLT to show the data. So basically, what this is doing is it takes the X axis. This is the X axis. Now it takes Y1 and X2. Okay, it combine the Y1 and Y2, Y1 and Y2, Y1, Y2. Okay, those two, it combine the values to get the highest point on these particular curves, combine both of them, get all the values for both of them. Okay. Now the y1 is cut here. Like okay, this is the portion for one. Okay, this is y1, right? This is the entire thing from beginning to the whole area is both of the values combined. Okay, but you want to separate them that okay, y1 covered this area, so this is exactly y1 values only. Okay, this is the area the y1 covered. Y1 cover the blue portion, and then so that means that up from here to here, this is the y1 coverage. Okay, okay, and then from here like this, okay, is the x1, the yellow is the x1 cover, I mean y2, we have y1, excuse me, y1, and then the y2 is the yellow is the value for the y2. Okay, this one where can it be used? I haven't really used this one for a practical before, but yeah. So each colored area represents a variable, and the size of the area, it shows its value over the x-axis. Okay, the areas are stacked. So the top line, it shows the cumulative total of all variables. Okay, the top is always the total of both of them. Okay, okay, and then compare the thickness of each area to see how each variable contribute to the total. Okay, this is the total of all of them. So if you look at this, y1 has contributed so much here to the total over here, and over here you see that here y2 has contributed big to this particular area. Okay, like over here, yeah, y1 has contributed, but if you see the value of, yeah, I think, yeah, over here y2 has contributed bigger. So yeah, so you can see it like that. All right, so that's the plots, the regular plots, and we can also have 3D plots. That is just something to just show up. Matplotlib can create 3D plots using it has a Matplot 3D toolkit, and the 3D plot, they are useful for visualizing data with three variables. You know, we have three variables such as surfaces, lines, and scatter plot in 3 dimension. You can create a 3D plot. So let's see how that one looks like. So let's say we have a z-axis here, line space from 0 to 1, we want 100 data points, and then x is just z times, we have some calculations, mathematics calculations here to get the data points. We have the x, the z, the x, and the y. That's the data point we have, and then we want to plot it. So we have the area, the figure, We plot the figure where we are going to have the graph. And then if you want to plot this, you say fit dot add subplot, okay, 1 1 projection equals 3D. This is the keyword. This is what's going to tell Matplotlib that I want to plot a 3D plot. Okay. Now, once you say that, then this particular x as, you are going to say as dot plot 3D. Okay, you are going to plot 3D. Okay, this is plot 3D means you are plotting a line in a 3D. Okay, and then you have x, y, z, the values that you have, gray. Okay, you want the color to be gray. All right, and then you set the title. So you see now we have this one is the this is the x-axis, this is your y-axis, and this is the z-axis. And then a line is plotted in this, and it's not easy to see things in 3D space, so don't even try to see, okay? Another one is this, scatter plot. You can do also scatter plot, see? Or you have 3 data points, and you also, the same thing you do the same thing, and then you just say as that as it does scatter 3D, and then the scatter plots are in 3D. Yeah, it's not easy to see it. So, but yeah, but yeah, you have to have a way to turn it. You can make it actually be able to turn it around and see the data set. For example, let's do something here, so that we can see this one in. Let's do something here. Let's do here. Matplotlib, mat Matplotlib widget. Okay. Okay. If I say Matplotlib widget, sorry, what is this? Matplotlib, is it widget? Yeah, widget. Yeah. Oh, I think I get that one wrong. Okay, I wanted to show you the 3D, but I think maybe I have that at the end probably. Okay, so the 3D plots, yeah, you might use it like for some situation, but really they are not used that much. I mean, in my own experience, I don't use it that much. So, but yeah, they are there just to know that it's there. Then that is Matplotlib. So Matplotlib is there, and then we have on top of Matplotlib, we have Seaborn. So Seaborn is just an advanced form of Matplotlib. Okay, so it's a visualization library based on Matplotlib. It provides a higher level interface for drawing attractive and then informative statistical graphics. What is it? It's built on top of Matplotlib for easier and more beautiful visualization. Seaborn is really beautiful. It integrates with pandas. It includes built-in themes and color palettes. Okay, so let's see some examples. So let's get that by importing Seaborn. We already import it already. The Seaborn actually has data sets already in there. If you want to sample data set, you can load the sample data set from Seaborn. You just have to know the name of the data set, and then you load it like this. There's another one data set, a popular data set called the ARIS data set. So you load it by saying the SNS dot load data set, then into bracket, then you put the name of the data set. As I said, one of them is ARIS data set. One of the most important library, probably you are doing machine learning, you'll be using it for testing to see your code is working. Okay, so let's look at it. Let me. Okay, see. Okay, so this is the ARIS data set. So this ARIS data set, it was actually some researcher that if you see it's a flower. The flower has a petal and a sepal. I don't know if you know what that means, but we are not here to petal and sepal of flower. Okay, you see this like over here, which one show better? Okay, this one shows better. See this one, the one outside here, the green one here is called the sepal. Okay, and the bright one that is inside is called the petal. Okay, so a researcher went around, okay, look at some flowers, the iris flower, okay, measure the length of the sepal, okay, then measure the width of the sepal that I just showed, then measure the length of the petal and measure the width of the petal. Okay, he did that this measurement for so many Irish, and then Irish have different species. We have Vetosa and Setosa. There are different. Is it four type we have? I say Irish, Irish species, not unique. Let's see. So we have Setosa, Veriscola, Virginica. Yes, so okay, so there are three types of arrays. So what happened is they take the measurement for different type of these arrays. So after time, they collected this data set and save it. Okay, so in terms of machine learning, I digress a little bit. What happened is if you know that they take all these data set, they have all this information, and then they know the species for it. Okay, they know the species for it for whatever it is. Then the machine can learn and be able to tell if in case next time you come and give a particular sepal length, sepal width, petal width, and the petal something, you give this data, the machine can predict and tell you it is a versicola or virginica or whatever it is. That is what one of the most important ways is used in machine learning for training your classification models. Okay, all right, so let's add a little digression over there. So that this is the data set, so we are just borrowing it here to do some visualization. Okay, I also put even some of the what this data set is. It's a classic data set in machine learning and statistics, included with Seaborn for just easy access. It contains 150 samples of Irish flowers from three different species: Setosa, versicola, and virginica. And each sample has four features: the sepal, the petal, all those levels. Okay, all right. So now we have that data set. Okay, it's commonly used for demonstrating classification, clustering, and visualization techniques. All right. So what we want to do is we want to plot different plots to see the data, how it looks like. So in Seaborn, you want to plot the graph, you say scatter plot. Remember in you say sns.scatterplot. In using Matplotlib, we say plt.scatter. But here in Seaborn, you say SNS, the SNS Seaborn library dot scatterplot. Okay, then data equals Irish. Okay, the data equals Irish. Now, what you are going to put on the x-axis, we are just saying we want to put the sepal length on the x-axis. On the y-axis, we want to put sepal width. Okay, hue equals species. So species is going to identify the color we are when we are plotting the point, what color we are going to use there depends on the species. If species is virginica, we will put green. If it is versicolor, we put yellow, and if it is setosa, we put blue. So when we plot this scatter plot, so you see the scatter plot, we say data for scatter plot equals the Irish data frame. This is very important. Then we specify the column that we are using from the data frame. So the column, so these columns are in the data frame. Okay, those are the columns. You see, at this time, this column we are specifying. So that's the value. When it's a data frame, you can specify directly the data frame columns. As far as you give the data to it like this, you specify the data frame column that you're going to use for the x and y axis, and the hue is the species. Okay, so now look at this. When we plot this for sepal length on the y-axis, and then sepal width on the y-axis here, and sepal length. And when we plot it, look at this, you can quickly see that the setosa flower has separation over here. You see the separation? It's quickly separated over here. Virginica and then versicolor, they are little mixed, but you can see a little bit somewhere here. You have some But yeah, if you are doing machine learning, that's where you cannot simply separate this. You cannot say, oh, if I draw a line here, it's going to separate these things separately. So you need to find a way to do the classification. But I digress. That's not the point here. But we can quickly. I just want the point is that you can have a data frame, quickly plot different type of plots. Okay. Histogram, you can plot histogram, the same thing. So we say here, we say scatter plot, and then here is hist plot. So Seaborn is adding plots to whatever, because in Matplotlib it's a hist, but in Seaborn it's just a hist plot. Okay, so the data equals the array data. Then we say separ length, and then this is what because histogram you have only one value, and you are going to put how many you put a bin and see in the value for us how many of them fall in that bin, and that will become the height of the bin. Okay, so for that particular separ length. Okay, so if you put the bin here, let's say the bin is from 2 to 4.8 or something. So the bin width is the same. So it will count how many of the x values fall here. So it will put over there. That's what it's doing. It's doing over here. Okay, that gives the length or the height of this value. The higher ones means that there's a lot of the separ length that is between these 5 to 6 to here. So there are a lot of them that have that value over there. So it's just that one value you are getting. What is the spread for the value? Okay, you can do boss plot that we did in Matplotlib, also in Seaborn. So it's boss plot. So this here actually is the same name, because boss plot is what is used in Matplotlib too. So we are using the same thing over here. SNS.blockplot, we give the data set, and then we specify the column X and Y, and then we get this. Okay, see this. So this is Setosa, Versicolor, and then Virginia. Okay, you see this like this. This is a boss plot. Okay, pair plots too you can do it, but this one, yeah, there's a pair plot. This is pair plot. So each pair will plot. It has, you see, at the bottom here, you have. This is probably too big. Yeah, it's probably too big for the screen. That's okay. It's one graph. So the point is you want to see many things at once on this graph. Okay, you want to see separ length against petal width. You see, this is what in the corner here in the diagonal. You see all these. This is the separ against the petal. This is the separ against the petal width. Okay, you see how these things look in the diagonal. You have the same graph, and then there is different type of graphs here, over here, over here, over here. So it helps you see, okay, in general, what graph give me a better understanding of my data set. So let's read over here. Okay, so let's read how to read it. So a pair plot shows scatter plots for every pair of numeric variables in a data set, and histograms, these ones, okay, these histograms, or is it KDs? Is I forgot the name for this. Okay, for each variable on the diagonal. Okay, on the diagonal. Okay, each cell in the grid, each of these cells compares two variables. Yeah, the x-axis and the y-axis. Okay. Okay. Now the diagonal cell shows the distribution of each variable. The diagonal shows the distribution. Okay. The points are often colored, yeah, by categorical variable. Yeah, like the species. The points are colored by that. So here you look for patterns, okay? You look for patterns, clusters, okay? Correlations or separation between groups across the scatter plot, okay? So they are useful for quickly visualizing relationships and distributions among multiple variables, and for spotting trends or outliers, okay? So we can quickly see different things here. So you can know which variables actually I can use to quickly do classification for the data set. That's how you can actually use this plot. You can see, um, yeah, so yeah, this is more just for normally visualizing the data for analysis as a higher level. You use this type of plot. Okay. Another plot, Violin plot, that's also there. Is just some fancy plot. It also shows the distributions of the data. Like, so we have the same another data set here in Seaborn. It's called tips, like the tips, people's tip or something. We here is just loading the tips data set. So as the data set is already in SNS for tips. So it has the day and how much total bill was like a bar, what is the total bill for that day. Okay, that's what it is. And then the data is the data. Okay, the data we are using, and then you use Violin plot. Okay, and then here we give the title, and the X label is the day, and then the total bill, like in the restaurant or whatever it is. When you have a bill, what is the tips, how much the tips is for that day. So this type of plot you can use. How can you use it? So the width of the Violin at each value. Okay, at each value shows the data's density, whether it's more data point. So for example, Thursday, if you see that this value, I think this is 15, if it is in $15, for example, you see there are more tips around this time. Okay, so there's more of the 15, there's less of the 30. Okay, less of the 40, and then 50. Okay, so you can really, like, okay, around this there are more of 15. 15 has more. So when this width is showing that the value that is showing it is big, there's a lot of them on that particular day. There's a lot of the tips on that day. Yeah, say it like that. A lot of tips on this day at this time. At this particular value, tips of $15, it was more on this side. Okay, you can read it like that, and that's what it's telling. The distribution here means that the value here, wherever these things are big, means that there's more of that value, more of the value in that particular area. Okay. Okay, another graph, a heat map. This is also available in Matplotlib, and it's also available in SNS. So heat map is it will almost look like a scatter plot if you want to interpret, but the colors give the density of the data. So here we got some data, right? Then we have the figure, and then for this one we say heat map. Then we give the data that we have. Okay, and then the color map, you just give it a color map, right? Then this is a title, then show. Then it's going to draw you the data, okay, that we are trying to see. So we have these. So wherever the data is more dense, it means that is where wherever the color is more dense. You see, the color comes from lower, and then it goes up here. Wherever you are going to darker colors, it means more of the value is concentrated in that area. For example, if you are monitoring data center outages and something like that, or security risk or attacks happening, and you are trying to track wherever it's happening, and the area that is having more of the data set, in that area, it will be more colored, darker, so people can quickly see. Okay, heat maps are good for spotting those things. You plot them in the color terms that this place is dark, then you know that, okay, something is happening around this area, so we need to investigate quickly. You don't have time. Okay, so how to read it? Each cell in the heat map, it represents a value with color indicating the magnitude. Okay, darker or lighter colors for higher or lower values depending on the color map. Okay, and the axis typically represent categories or variable, time or features or groups. You use the color bar. This one is called the color bar. This one at the end here. is the color bar. You use it to interpret what each color means in terms of value. So like from here to here, it will be like 0.2 to 0.3, something a little bit lighter. When it gets to 4, 0.4, the value. So this is what you're going to use. So, okay, so more higher numbers are going to have darker colors. So here means that, okay, the higher numbers here are actually located in this area. You can quickly see it from the graph. Okay, now after doing all that graph, you can save it. Okay, you go back to plt.savegraph. That's the command. Then you give the name to save for the graph. PLT means that this is the graph, the last graph that you have drawn. Like if we, after we drawn this histogram, we have done this histogram. Okay, once we finish drawing, because I did not run all these. Oh, let me just start it from here. From from NumPy, import NP. Okay, let's see. Import import NumPy as NP. What am I mean? Import NumPy, import NumPy as NP, import num NumPy as NP. Okay. Yeah, import Matplotlib. All of them are here. Okay. Now let me go here and say, here I'm just drawing a graph, histogram. Now I have the graph over there and I want to save the graph. I say my histogram, my histogram, okay, dot png. So because this is the graph that I just drawn, okay, the plt have it have the graph. So I just say plt dot save fig. Then I give the name that I want to save for the graph. And then when I save it like that, I should see the graph here, my histogram.png. And then what? It didn't have it. Plt.show and plt.save. Why are all the graphs gone? Okay, yeah, this is how you save. Let me do another one for, I don't know why that one is not drawing it, but let's go and let's do the line graph again, or any of these ones here. Okay, any PLT, the latest one you have, when you say save it, you should save it. I just don't know why it's not saving that one. Did he save it now? Okay, there's a problem or probably some issue. But yeah, you can just save the graph by saying plt.savefig. Then you give the name and it will save that graph over there. So what did we do today? We know that Matplotlib is great for full control and customization of the plot, and the Seaborn makes it statistical plot easier and more attractive, especially with pandas and data frames. Yeah, so if you want more beauty with the graph, then Seaborn is the one you can actually get more beautiful graphs. But Matplotlib gives you greater control when you're drawing the graph. So it's up to you to come up with, to do anything. You can use any of them. So here, this is the quiz for today. Okay, for this quiz, we're just going to be drawing some graph and see how it looks like. So you get to appreciate the visualization. This should not be any long work. Okay, so you should do that to see. Okay, so you are given a data frame DF with columns A and B. You are going to write a code to create a scatter plot using Matplotlib, where the axis is column A, the x-axis is column A, and the y-axis is column B. Then you add appropriate labels, axis labels, and the title. So basically, and a bonus point, how would you change the color of the points to red? Okay. So example, we are creating a data frame for the quiz, right? So we have pandas, we have NumPy. So we are going to create a data frame with columns A and B, okay? napa.mp.random.seed is just a way of we seed the performance so we can reproduce whatever we do. So I say the data frame, I say pd.data frame, okay? So dictionary here. Now specify column A. I have the values mp.rand 50 numbers are going to come there, and then B also 50 numbers. So when I see the head, I have this number. So I have A and B. So this data frame, use it to do this practice quiz. Okay, and then try, do the first one. Then the next one is change the color to red of the line plot as a second graph. Okay, all right. Thank you for watching this lecture.